Hi, this is Hari Babu, working as Associate Professor in EC Department of MLR Institute of Technology. Today, we will discuss about probability density function. So, first of all, what is meant by probability density function? The values of the probability at the given value of random variable x is called probability density function. Otherwise, the derivative of probability distribution function is called probability density function. It is denoted by small fx of x equal to d by dx of fx of x. So here we can represent in terms of discrete manner and continuous manner. So generally continuous means we need to define the values of the probability at the given value of x, that is small fx of x equal to d by dx of capital Fx of x. So in terms of discrete manner, so that is small fx of x is equal to summation of I equal to 1 to n p of xi into del of x minus xi. So how to get this probability density function from probability distribution function? Already we know probability distribution function, that is capital Fx of x equal to summation of I equal to 1 to n p of xi into u of x minus xi. What I know? So that is probability density function is differentiation of probability distribution function. So that is I need to apply derivation for the distribution function. So that is d by dx of capital Fx of x, that is d by dx of summation of I equal to 1 to n p of xi into u of x minus xi. That is p of xi means this is the constant value, that is p of xi into d by dx of u of x minus xi. U means this is the unit step function. Derivative of unit step function is, that is impulse function, that is p of xi into summation of I equal to 1 to n del of x minus xi. So simply we can write small fx of x is equal to summation of I equal to 1 to n p of xi into del of x minus xi. So this is the probability density function from the probability distribution function. So next we need to know what are the properties of probability density function. First one, the probability density function is always non-negative real number. So here what I am telling, what is the probability density function? Probability density function means that is the probability. What we know the properties of probability? The probability minimum value must be taken as 0 and maximum value of probability will be taken as 1 only. That is non-negative real number only. That's why the probability density function, otherwise probability value must be greater than or equal to 0. So this is the first property. Next we need to see the second property. So that is the area under the density function is always 1 only. That is integral of x equal to minus infinity to plus infinity small fx of x dx equal to 1. Already we know the relation between probability distribution function and probability density function. What we know? Capital Fx of x, that is probability density function, small fx of x is equal to differentiation of probability distribution function. Now I need to apply integration on both sides. Integration from x equal to minus infinity to plus infinity. So we can write, that is integral of x equal to minus infinity to plus infinity small fx of x dx equal to integral of x equal to minus infinity to plus infinity d by dx of capital Fx of x with dx. There is no change in the LHS, that is integral of x equal to minus infinity to plus infinity density function small fx of x dx equal to, here differentiation, integration both are cancelled, but I need to substitute this upper limit and lower limit instead of x. So I can write fx of x, that is fx of upper limit infinity minus fx of minus infinity. See here, there is no change in the LHS, that is integral of x equal to minus infinity to plus infinity small fx of x dx equal to, here we know already the properties about probability distribution function. Here the probability distribution function of infinity is always 1 only and fx of minus infinity, so always 0. So here integral of x equal to minus infinity to plus infinity small fx of x dx equal to 1. So this is the second property. Next we need to move to third property, that is integral of x equal to minus infinity to x small fx of x dx equal to distribution function. This is also called as the relation between distribution function and density function. So here already we know the relation between probability distribution and density function means, that is d by dx of fx of x is equal to small fx of x. Now I need to apply integration on both sides with x equal to minus infinity to x. So we can write integral of x equal to minus infinity to x d by dx of capital Fx of x dx is equal to integral of x equal to minus infinity to x small fx of x dx. Here differentiation, integration both are cancelled. Now I need to substitute upper limit and lower limit instead of small x, that is capital Fx of x minus capital Fx of minus infinity is equal to integral of x equal to minus infinity to x small fx of x dx. So here we know already property of probability distribution function, that is capital Fx of minus infinity is always 0 only. So we can write capital Fx of x is equal to integral of x equal to minus infinity to x small fx of x dx. So this is the proof of third property. Next, fourth property, that is we need to prove that p of x1 less than x less than or equal to x2 is equal to integral of x1 to x2 small fx of x dx. See here, I am assuming two conditions, that is x less than or equal to x1 and x1 less than x less than or equal to x2. Both are, there is no common between these two elements. So I can write x less than or equal to x1 plus x1 less than x less than or equal to x2 is also written as x1 raise x less than or equal to x2. See here, for example, this is my random axis. Here assume this is my x1 and this is my x2 variable. What I am telling, from minus infinity to plus x1, this is my first event, and x1 to x2, this will be taken as my second event. Here there is no common between these two events, means simply I can write x less than or equal to x1 plus x1 less than x less than or equal to x2 is also written as x less than or equal to x2. Now I need to apply probability on both sides. Apply probability. So we can write p of x less than or equal to x1 plus P of x1 less than x less than or equal to x2 is equal to P of x less than or equal to x2. So here I need to move this P of x less than or equal to x1 to the right hand side. So I can write P of x1 less than x less than or equal to x2 is equal to P of x less than or equal to x2 minus P of x less than or equal to x1. So there is no change in the left hand side function, that is P of x1 less than x less than or equal to x2 equal to, see here, P of x less than or equal to x2, that is called as probability distribution function. So I can write capital Fx of x2. Similarly, this one also probability distribution function. We can write Fx of x1. See here, we know already third property of probability density function. What we know? Fx of x equal to integral of x equal to minus infinity to x small fx of x dx. So I can write, instead of this distribution function, we can write integral of x equal to minus infinity to, see here, this is my upper limit, that is x2 with small fx of x dx minus, see here, this one also I can write in terms of density function, that is integral of x equal to minus infinity to, this is my upper limit x1 with my density function small fx of x dx. See here, what I am telling, I need to find my density function up to x2. See here, this is my x-axis. What I am telling here, this is my x1 random variable, this is my x2 random variable. I want to find the area from minus infinity to x2, this one, minus, I want to find the area between minus infinity to x1, that is I want to find the area between x1 to x2. So what will happen? We are finding the area between x1 to x2 only. So simply I can write integral of x equal to x1 to my upper limit is x2, x2 with my density function fx of x dx, that is P of x1 less than x less than or equal to x2 equal to integral of x equal to x1 to x2 fx of x dx. So these are the properties of probability density function. Now we are moving to the related problems of probability distribution and density function, and we will draw the graph related one. See here what he is asking. A random variable x has probabilities shown in the table. From that one, you need to find the value of k. I need to find the value of k and find probability distribution function and probability density function and draw the graphs for that one. So first of all, we need to find the k value for this one. If you want to find the k value means, first of all, we should know what is the total probability of this one, whatever may be. Simply we can say that the total probability, the probability of sample space is always 1 only. In that case, my sample space contains -3, -2, -1, 0, 1, 2 only. These are my sample space elements. This contains the probabilities of 0.2, 0.5k, k, 0.1, 0.3k, k. So what I am telling is simply the total, all these values must be equal to 1. That is the probability of sample space. So now we are finding the first bit, that is finding k value. If you want to find the k value means summation of I equal to 1 to n p of xi is always 1 only. So this is the probability of sample space. So now I can write probability of point, that is I can write p of -3 plus p of -2 plus p of -1 plus p of 0 plus p of 1 plus p of 2 is equal to 1 only. So P of 3 means what is the value? That is 0.2, 0.5K, K, 0.1, 0.3K and K is equal to 1. So here the total K value is 1 by 4. This is the first bit. Next, I need to simplify that one. That is my table. That is 0.2, 0.5 into 1 by 4. That is 0.125. This is 0.25, 0.3K. So this is 0.075 and K. This is 0.25. So now I know already all these values. That is minus 3 value is 0.2, minus 2 value is 0.125. I want to write at the time. That is X and P of X. That is X values are minus 3 with the value 0.2 and minus 2, 0.125, minus 1, 0.25, 0, that is 0.1, next 1, that is 0.7075, next 2, that is 0.25. So in that case, these are my random variable values and probabilities. Now, what is my second bit? I need to find probability distribution function. How to find the probability distribution function means we know already how to find, that is probability distribution function is equal to P of X less than or equal to X. So now I need to find Fx of minus 3. That is P of X less than or equal to minus 3. Here, what is the less than or equal to minus 3? So that only minus 3 value, and there is no less than minus 3 values. That's why simply we can write P of X equal to minus 3 value only. That value is 0.2. Next one, I want to find Fx of minus 2. That is P of X less than or equal to minus 2. Means we can write P of X equal to minus 3 plus P of X equal to minus 2. That is 0.2 plus 0.125. 0.325 is 0.73375. Right? Next one. Fx of minus 1. That is P of X less than or equal to minus 1. That is 0.375 plus 0.25. That is 0.525. Next, I need to find Fx of 0. So I need to write 0.2 plus 0.125 plus 0.25 plus 0.1. Similarly, Fx of 1, that is 0.2 plus 0.125 plus 0.25 plus 0.1 plus 0.075. Similarly, I need to find Fx of 2, that is 0.2 plus 0.125 plus 0.25 plus 0.1 plus 0.075 plus 0.25. So total value is 1. So if you want to draw the graph means, this is my random variable, this is my probability distribution function. So here my value is starting at minus 3, that is X equal to minus 3, minus 2, minus 1, 0, 1, 2. So at X equal to minus 3, my value is 0.2. Assume this is 0.2. Next one. So same value is continuing up to the next sample. My next sample is X equal to minus 2. So same magnitude is continuing. At minus 2, my voltage is 0.2 plus 0.0175. That is 0.375. Next, at 1, my voltage will be taken as 0.175 plus 0.25. That will be getting as 0.445. So on, it will be increasing. So here at 2, my voltage will be getting as 1 only. So this is the probability distribution function and a graph of the probability distribution function. So in that case here, -3, -2, -1, 0, 1, 2. These are the discrete random variables. These are totally discrete random variables. Now, I need to find probability density function also. So here, my values will be taken as x and p of x. Here, x will be taken as -3, that is 0.2, and -2, that will be taken as 0.125. Next, -1, that is 0.25, 0, 0.1, and 1, 0.075, and 2, that value is 0.25. So now, I want to find probability density function means fx of x is equal to d by dx of capital Fx of x. So here, my random variable x is discrete random variable means simply I can write fx of x is equal to summation of I equal to 1 to n p of xi into del of x minus xi, that is p of -3, that is p of -3 into del of x minus of minus, that is del of x plus 3 plus p of -2 into del of x plus 2 plus p of -1 into del of x plus 1 plus p of 0 into del of x minus 0 plus p of 1 into del of x minus 1 plus p of 2 into del of x minus 2. See here, p of -3 means my voltage is 0.2, my probability value, that is 0.2 into del of x plus 3 plus 0.125 into del of x plus 2 plus p of -1 means 0.25 into del of x plus 1 and p of 0, that is 0.1 into del of x plus p of 1 0.075 into del of x minus 1 plus 0.25 into del of x minus 2. So this is my probability density function. I want to draw the graph for this one means this is my random variable, this is my probability density function magnitude. So here, this is my -3 sample, -2, -1, 0, 1, 2, like that. So here, at -3, my voltage is 0.2 and -2 voltage is 0.125 and -1, the voltage is 0.25 and 0, the voltage is 0.1 and 1, the voltage is 0.075 and 2, the voltage is 0.25. So this is the graph for the probability density function.